Hey girls, so tomorrow we're going to start coordinate geometry, in particular straight lines. Most of this is straight out of Year 10, so we'll go fairly quickly. So first thing we need to do is the slope. So there's my axes, let's pretend I've labelled them, and then let's just plot 2 points. Let's plot this point here, which we'll say is at -1, 1, and then let's plot this point over here, which we'll say is at 5 and 4. So the way I think you should do it personally is always just imagine a triangle. And we're going to do the same thing for the distance formula when we get there. And then we always just do slope. Is the most important thing is that it is rise over run. So this thing goes from 1 up to 4. So that is a rise of 3. And at the same time it goes across from -1 over to 5. So that is 6. So the slope of this particular line segment is a half. We can also read the slope of lines by taking the m here. M is the slope of a line. The other thing that I'm not sure whether you would have seen in Year 10 is that if you've got any line at all, and you take this angle here, sorry, there's a plane, hopefully you can still hear me, so the angle of the positive x-axis to the line, then there's a theorem that says that the slope of that line is tan theta. Now if you think about why that is the case, if I construct a right angle triangle here, there's the rise, there's the run, and hopefully you can see that tan theta equals the rise over the run, opposite over adjacent. So that's another formula for the slope that's really quite important. Now when it comes to slope, there's a couple of other things to consider. Sorry, my iPad just paused, I may have doubled up there. But firstly is that parallel lines, we've talked about all these things before. So they have the same slope. That's the definition of parallel. And then perpendicular lines have slopes that multiply together to give -1. M1 times M2 is -1. You'll hear people start talking about negative reciprocals and things like that. And that's what they mean when they talk about perpendicular lines. Now the next thing I want to talk about is the equations of lines. And again, we've done all this. The one that I like is mx plus b. Right? I think, and every equation that you get can be turned into this format. The reason I like it is you've got a slope. Yeah, it happened again, I don't know why. You've got a slope and you've got a y-intercept. And if you've got a y-intercept and a slope, then that's how I like to sketch my curves. So, you tell me the y-intercept is 3 and the slope is -1, then I draw a line through -1 with the slope, a line through 3 with a slope of -1, and I use that to work out that value there is 3 as well, using the slope. Another formula that is very useful is point gradient formula. We will use this quite a lot. So that's where we've got the slope m, and we've got a point that we know is on the line x1, y1. And so there's a bunch of things that we've talked about. So for example, we could say, how do I know that the point 3, 2, how do I know whether that is on the line y equals 2x minus 1? Well, this would be a case of doing right hand side equals 2 lots of 3 minus 1, which is 5, which is not 2, so it's not on the line. Right? If it were 2, it would be on the line. And the other thing that I'll get you to practice tomorrow that we've talked about before is finding where two lines intersect. So where does y equal 2x plus 1 intersect with the line y equals 7 minus x. And you do that by simultaneous equations. So you just go 2x plus 1 equals 7 minus x. X, what is it, 3x equals 6. Oh, that was nice. So x is 2 and y is 5. And then you're finished. Okay, and we've done that tons of times before. And then, so we've got 2 hours tomorrow. We'll do a lot of practice. And yeah, that's all from me. See you tomorrow.